This video demonstrates the Android-based Common Meter Reading Instrument, CMRI, which uses the EIN Renaissance Zigbee module to communicate with remote meters. The CMRI is used by meter reading personnel that walk around to metered sites. The CMRI establishes communication with the meter, typically using line-of-sight optical communication, and retrieves consumption information 1 meter at a time. Our solution uses a Zigbee network based on Renaissance and EIN technology to establish communication with meters over an RF network, and extracts data from every meter that is part of the network. The meters no longer need to be in line of sight of the CMRI, and they may even be in neighboring buildings. This demo uses a ZenithInc with an ARM11 processor that is running on the Android 2.2 platform. It is connected to an EIN Renaissance Zigbee module on the USB port. And over here it is communicating with an HPL meter that exposes 4 communication lines to this other Zigbee module. The 4 communication lines are the 3.3 volts, the hot ground, and an RX-TX communication pair. The communication lines are being monitored real time with the scope. So the communication starts at the CMRI, flies from the Zigbee to the other device, and then communicates with the meter itself. The Android platform is based on Linux and is rapidly becoming the dominant platform for smartphone and smart device market. This has resulted in inexpensive hardware platforms that have a lot of peripherals and strong software support. This development tablet has a camera, Wi-Fi, and Zigbee. Other devices, such as the cell phones, include GSM and GPS. When we start the demo application, it comes up with a company splash screen. In this case, we can replace with any screen that you'd like, and clicking on the screen can bring you to user documentation for the application or to a support website. When this activity starts, it establishes communication with the USB module. Here, the USB module more or less provides a pass-through interface, and all the protocols are implemented right on the Android activity. This provides us with a very flexible system and also facilitates development. We can then switch to the network screens. And here we've actually got 2 networks listed. These networks are populated from a database, and they include very specific parameters for the network. If you enter one particular building, you want to be able to have one network with one set of parameters. And moving to another network allows you to change those parameters themselves. At this point, we'll start up the second network. Would you like to form the network airport? It said yes. This sends a command to the module, and then when the module comes back and says that the device has been formed, it will also update the status of that particular network. Now, we're part of the network and we're waiting for new devices. We can go to the devices window, and currently we don't have any devices listed. Now, devices will typically be pulled from the database, and then they will populate this list. This will consist of a list of allowed devices for this particular network. For our purposes, we have this list which is empty and is populated dynamically when devices are added. Now, we're going to be powering up the meter. And by powering up the meter, we'll establish communication between the Zigbee module to this one over here. Then, this module will start polling, or the activity will pull data from the meter, and then we'll see messages pop up as toast as new data arrives, and we'll see the communication lines. The meter has been powered up, and we can immediately see data is communicating, and a new device has been populated in our list. And as data comes in, we are getting more messages come in here. Now, communication has stopped for quite a while. However, the toast messages take some time and they've been queued up. As a result, the toast messages in this case will end much later than the actual serial communication. This data that's incoming is stored in a local database, and it is once the data is completely available, then it can be uploaded to a major or to the central server over the GSM network. The Android platform also provides a camera interface which allows you to take pictures of the meters that we are reading and to record instances and GPS coordinates of tampering events. This concludes the Android-based CMRI demo. If you have any questions about this technology used in this demo, then you may contact Renaissance Singapore India branch or EIN's Technical Support Department.